Welcome, everyone, to Talking Textiles. I'm Mark Tyrell, a member of ATA's Canada Division, and I'm joined by co-host Ryan Mischik.
Hello.
The goal of this podcast is to get to know a wide variety of positions and markets that make the advanced textiles world turn. We will be talking to professionals in different roles throughout this series to help inspire the next generation of textile professionals and anyone interested in learning about others' journeys within the world of textiles. ATA offers advanced textiles content throughout the year, including the upcoming Advanced Textiles Expo taking place September 24th to 26th in Anaheim, California. Please visit textiles.org/events to learn more. On today's episode, we're speaking with Justine Decaens, Director of Research and Development from CTT Group, which stands for Collegial Center for Technology Transfer at the Cégep de Saint-Hyacinthe, which is a nonprofit organization specializing in applied research, development, and analysis in the field of technical textiles, geosynthetics, and advanced textile-based materials located in Quebec, Canada. And now, let's talk textiles. Welcome to the podcast, everyone. Ryan, first-time co-host.
Thank you, Mark.
And Justine, thank you very much for taking time out of your busy day to join us today.
Welcome.
I think the first thing is we'd love a little bit of a background and to understand a little more about CTT Group and what exactly is the raison d'être or the purpose of CTT Group, and then a little bit more about what goes on there.
Sure. So as you mentioned, CTT Group is a non-for-profit. We're a collegial center for technological transfer. So there is about 50 of them in Quebec. They have a specific status on different aspects. So CTT Group is specialized in textile and geosynthetics. There are others that are specialized in metallic products, in software, in a little bit of everything. And the purpose of this type of research center, they are really there to support industrial development. So if an industry had let's say a project in research and development, sometimes they don't necessarily have the capacity to develop it in-house, as they're not the human resources nor the technologies. So they ask for our support, so we can help them develop the product up to a certain point, and then we help them do the transfer, so either in-house or with another partner, manufacturer, for instance, that will be able to help them put the product on the market.
Oh, wow. So you're actually involved in the development process, not really just testing to see if a product meets certain criteria or meets like specifications.
No, exactly. We really are involved in both aspects. So we have in CTT Group, we have two teams. We have a research and development teams where we do a lot of prototyping in different aspects. So it can be in textile, in chemistry, if it has to do with coatings or membrane that we will laminate onto a textile. So we have all these aspects of prototyping, of developing different structure, and we are lucky to have a lot of different equipment so that we can cater to all sorts of needs from the industry, ranging from yarns, non-woven, woven, knitted, and all the finishing as well. And then we have the laboratories, which is able to test the prototypes, make sure that they meet the specification required. We work a lot for the industry. So everything to do with specification, for example, for firefighter, military, everything to do with personal protective equipment, there is a lot of testing according to certain specifications that needs to be done. So we are well equipped to do that. And so once we develop a product with a company, we test it to make sure that it meets this specification and that the product will be able to go onto the market after that.
Oh, so I feel like that just opened up. Like I think we probably have enough material there for like multiple podcasts. But I guess the first question that came to mind is how do companies find you? How do they because I realize like we're almost next door, like we're only an hour and a half away, and I really thought it was a test facility. I thought it was just about testing to see if materials or fabrics are meeting the criteria they say that they're meeting, the specifications that they say they're meeting, or to test to certain regulatory specifications. But now you're actually also involved in the development of products and really in helping companies get their product to market and, go through all those processes. So how do companies find you in general, I guess would be
So actually, you know what? We are a really well hidden secret. So a lot of
apparently.
people, a lot of people comes to us through the laboratory aspect. So, they send their product to be tested, and sometimes the product doesn't pass, and then they ask question, how could we do differently? They ask for some advice, and so they are referred to the R&D team, and a lot of them, that's how they end up knowing all the different services that we offer. So yes, it's a lot of once we start a relationship with an industrial for the R&D, it becomes bigger and bigger. But to know all we do, it's and that evolves constantly, right? Because there is always constant new needs, new equipment that we acquire. So just in 2024, we will have for over close to 2 million of new equipment coming in, and so even the partner with who we work regularly on a regular basis, they don't always know all what's going on there. So it's good for them to learn about it.
Nice. So is that some of the most fun, just getting new toys to play with on a regular basis?
Well, as a research center, we have to be at the high technology, right? We have to be ahead. So we are looking at what's coming, and we try to acquire the equipment ahead before it becomes standard, right? So the company that work with us can benefit from developing technologies ahead of time, and then once it's ready to get to the market, well, they have a timing advantage, I should say.
Nice. One of the things that we love on the podcast is really kind of getting the individual's backstory and maybe origin story. So, read in your bio that you have a bachelor's degree in textile engineering, and then I believe it was a master's in mechanical engineering. But was that specific? I'm not sure if that's specific to fabrics, but wondering, how did you get involved in this? Did you have a passion for fabrics early on, or what brought you to this point?
Well, so I studied in France, and I was looking at so the timing there, it's a bit different. So you go to school, and then you have to pick a specific engineering school. So it's not a common general program. It's really already from the beginning. It's already specified to what type of material, so what type of engineering you will be working with. And I had a very hard time trying to figure out. I had a lot of interest in aeronautics. I had a lot of interest also in buildings and civil engineering. So I was kind of going from one to the other, trying to figure out what could be the right choice for me. And then I noticed that textile is kind of like everywhere in the aeronautics. We have a lot of projects for the composite part, for reinforcement of composite. We have a lot of things that are ongoing for the geosynthetics and the civil engineering, where textile is also involved. So textile became kind of like a common point to all of those sectors that were of interest for me. And so I thought, well, that's the best of both worlds, of all worlds actually, because it's kind of covers everything. And I got to say, I haven't been disappointed, because I've been in the field of research and development at CTT Group for over 10 years. And every day it's new projects that I would never thought about, like last year, for example. And it's always very different. In 10 years, there haven't been two projects that were not even kind of the same. They're always very different. So that's very great.
That's amazing. I think most people would hope for that kind of variety, I guess, in their work and in what they do. It sounds pretty impressive, but at the same time, I mean, is it overwhelming at times to be dealing with such different things, I guess, on a regular basis, and having to somewhat, I mean, reinvent the wheel?
Yeah, it can be. Sometimes you will wish that it was something that you have already done, so you could have already have the answer. That's the scary part of the research and development. When you get into a project, you never know what you're gonna find at the other hand. Is it gonna be very disappointing that, oh well, that's just not working, and then you got to close the project and that's the end of it? Or you get something that's actually super interesting, and then you keep digging and end up with the newest innovation that's becoming a big thing in the industry. you never know where it's gonna take you, right? But yeah, it's challenging. It's also sometimes the partners they would like more reinsurance. They would like to know, if we get into this, will we have something? And we can't give any promises, obviously. So for them, it's also kind of taking a leap of faith, right? So it can be scary, but it's very, very interesting.
Yeah. Does anything come to mind specifically, maybe a client or a project that maybe seemed small, but then ended up just completely, being revolutionary or changing an industry?
Well, I can talk about one recent project that we have done, and it was in regards with the membrane for firefighter gear, and we were looking at products that would be more ecological. And at that time, the issues about the PFAS were kind of going on, but they weren't at the point they are now. So when we started the project about almost 2 years ago, and we started that, and we keep looking at different options, and finally we find out a product that was working well. And today the product has been certified UL, so it's on the market, it can be used for firefighter, it's PFAS free, and it meets all the specifications. So at first it was not something, and it's one of the first products of this kind to be able to reach that level of specification and be PFAS free. So at the beginning, we were just trying to look at alternative. We didn't thought we will get to that point so quickly, but so it started small, as you mentioned, but it ended up being a very big innovation.
Cool. Yeah, that's amazing. I mean, I can just imagine uh, the variety of projects that come across your desk or that your company engages in from all industries, really. I mean, you said it when you were looking for an engineering major that yeah, the textiles really does kind of touch everything, encompasses all industries.
Yeah, really, and there is common point, right? Because for example, we're looking a lot at natural fibers. That's one example that comes to mind, and we are thinking, okay, well, natural fibers you can find, for example, milkweed. You can use it in insulation for garments. But then there is also hemp. The hemp you can start using that in composite for reinforcement. So it's still natural fibers, but then it becomes a wide variety of application, and that's just for the few that comes to mind. But there is still many more to be explored.
Yeah, definitely.
That's actually a hot topic for us right now, or at least it's beginning to become one in the U.S. Specifically, I think California is going to be outlawing PFAS in I think all of its products. Certainly, it's affecting the textile industry, and now it's affecting our industry. I think that's by 2025. There's other states that are coming on. Where I haven't found exactly how quickly Canada is going to be doing something similar, or what kind of regulations are coming down the pipeline. I don't know. Are you aware of that, or have you heard how quickly that's going to happen in Canada, and if there's and what the plan is, I guess, in that sense?
So actually, at CTT Group, we started the research chair named Eco Textile, and it's my colleague Ahmad Ibrahim, who is the chairholder, and he's dedicated to the PFAS-free research. So he's really the best person to talk to about this. So I know a little bit also from the different R&D projects that we work on together. Definitely, we don't know at this point what will be the outcome and when it will affect the regulation here in Canada. But the thing is, most of the manufacturers here in Canada, they also export in the US. So even if the regulation doesn't apply yet here in Canada, that still will affect the way they produce the garment or the fabric. Because if they want to export it, they will have to comply also with the US regulation. So I guess they are not in this mindset of waiting for it to come here. Most of the industrial partner, they are already looking actively for solution that they can implement as quickly as possible. Then the issue is always to try and find a balance between the price that we don't want to increase, the durability of the treatment, the performance, especially when it touch personal protective equipment. You can't really negotiate on the performance. It has to meet the specification all the same. So trying to find the balance between all of those different parameters, it's really where we are at right now.
Wow. Because I mean, that's a lot of different implications there, especially when you speak to safety. For us, it's as simple as, are we getting the same waterproofing, stain resistance, oil resistance, but really that's for aesthetics and some functionality sort of thing. But when you're actually dealing with people's safety and you've got to find an alternative that's going to have that same performance, it must be quite the challenge.
Yes, it is, and it's also the fact that there is a different part of the PFAS. So there is a oil repellency and there is a water repellency. The fluor elements are able to cover both, to provide both oil and water repellency. That there is on the market solution for water repellency that's silicone based, and they're working well, but they do not provide any oil repellency. So right. Depending on the market that you are targeting and the specification, sometimes you may be able to find alternatives that will suit your needs. If you don't need the oil repellency, if you're just looking at water repellency, you might be able to find already commercialized products that are PFAS free. But then when you start to add some complexity about durability, resistance to washing, it all comes down to where you want to get your product to. It's and the specification are there to guide you for that. That's the level of they give you the level of performance you have to reach no matter what. So then it's all trying to get to that point.
You know what? I had heard the same thing already. So it's interesting that the challenge is, I guess, the same across the board. Is that the water repellency is fairly easy to attain, but that the oil or resistance to oil or oil repellency is so far the tougher nut to crack, I think.
Yeah, it's a combination of both that is difficult to reach if you don't want to have, because it's also a question of not wanting to have 50 different treatment and product that will make the manufacturing process a nightmare. The new product has to be able to be used in the process as it is right now, almost as it is, but we cannot change the entire manufacturing chain to accommodate new product either.
Yeah, I think it's probably gonna be a tough go. So you guys at CTT, you're being called upon to help in developing, I guess, the different products, I guess, in the textiles that customers are bringing to you.
Yes, exactly. So we try to find different alternatives. Again, we always look at what is needed, because we don't want to be in the overachievement and propose a formulation that is going to cost 3 times the price and that provides great result, but it's not necessarily the result that they all need. So we're trying to really stay close to what are the needs and then provide formulations that are suitable for that.
Nice. Well, hopefully we can get on top of it and we'll be able to have, what we need in our industry. I would imagine, in every obstacle, there's opportunity, right? So there's going to be, the next great thing. And if eliminating those forever chemicals, the way they're called, is in everybody's best interest. And there's going to be, new products that are going to come out and treatments and, and maybe it's just going to mean we're going to have to, treat these fabrics on a more regular basis. And it's going to create, an opportunity for a whole different service that goes into our industry.
Yes, exactly. And actually, one thing that's interesting, what I was mentioning, the diversity of product and the diversity of projects, it's also related. So, we're talking about the PFAS and we're thinking, well, it's a common issue for all fabric. But at the end, when we're looking down to each project, they are all different. And there isn't one solution that will fit all of the needs. So because the formulation will depend on the nature of the fabric. Is it a polyester? Is it a nylon? That's not going to be the same formulation just right there. And then does it has to withstand washing, commercial washing, the domestic washing? And so all of those different questions, they all become kind of like a tree that's spread out, and they all have so many different variety of formulations. So that's just an example when I was mentioning the diversity of the projects that we are having. even though, well, okay, we're dealing with PFAS, that's kind of like one project. No, it's actually becoming 30 different projects because they all are different. And there isn't one solution that we develop that we say, oh, okay, well, we're gonna be able to use that for all of these other products. They all are gonna be different anyway.
That's another testament that every single project you work on is unique, right? Has unique applications and unique characteristics. Yeah. I saw on your website it mentioned smart textiles. And that caught my attention. I'm not really familiar with them. What are those?
Yeah, so actually we worked on Smart Textile for many years. So the idea is to integrate electronic components onto a textile to be able to have functions such as lighting, heating elements, and sensors. So there has been many companies, well, not many, but several companies that maybe you heard of. Exoskin is one of them, and they have integrated sensors into the shirt. They even use it into space. So there is lots of application where we want to be able to sense some physiological signs, heart rate, respiration, for instance, but we don't want to have these big sensors that are hardware, and they are not comfortable to be worn on a long period of time either. So we try to find alternatives of how to use conductive materials to integrate it into a textile so that the overall product remain flexible, remain comfortable to wear as well, and still we get the signal or the data that we want.
Cool. So what type of sensors, like what type of information are they gathering?
Some of them are related to physiological signs, so heart rate, respiration, mostly. Then you have also everything to do with pressure mapping. So, for example, either for insoles, for mattresses, so that's more for the medical sector. But people who lay down in the hospital bed for a long period of time, you need to know where are the pressure points so that the medical staff are able to move the patient accordingly to that data. There has been so many applications. There has been application in sportswear as well to be able to know the performances. So they had, for example, tennismen. They had like a shirt that had integrated a sensor at the level of the arm, so that on his phone he could replicate really the movement that the person was doing and be able to correct it if it wasn't good or if it was not exactly the way it should be. Application in sportswear in the medical sector, those are the two main application or area of application. But there are many other. In the more, I should say, for everyone, the heating textile is really what you can see, and you can already find some example of if you go to a store like Sales in Quebec or any outdoor store, you can find like heating glove, heating socks if you're doing skiing. Those are already commercially available.
Yeah, I never really put two and two together there. That's awesome. So that's definitely something we're going to see more of. The fact that you can fix my backhand in tennis, I think that's pretty incredible.
It helps with the diagnosis. I don't know if it'll actually fix it though, right?
We'll see.
You touched on a lot of different industries and I guess a lot of different markets. There's just is there a particular market that you feel, or I guess applications that are really driving the most innovation or the most forward thinking in terms of the use of textiles? And then I would imagine it ends up getting shared to the other ones. But I'm just curious if it really kind of starts in the in the medical side, or if it starts in the sports side because there's a lot of money there. What I mean? Like just curious as to what's driving it maybe and kind of sharing with the others.
From my point of view, what I've seen, there is a lot of research in the field of personal protective equipment. So that it's either, I was mentioning firefighter, military, though military it's a bit on the side, but it still fall into the same category. For example, the petroleum industry, everything to do with the coverall. There is a lot of innovation that's going into this direction. The medical sector, it's a bit more complicated because it's so structured and so hard to get into that market that it kind of cool down the motivation, I should say, of people that want to develop new products. Usually they will stop at the level, because there is different classification, but you can manufacture products that for the well-being. So the well-being, you have a lot of innovation, but it's not considered actually as being part of the medical field as it is. What I found the most innovative and what I see the most project going through is really the field of personal protective equipment.
Oh, it's interesting. I actually would have guessed maybe medical and and maybe athletic is what I was thinking of, but yeah, I guess personal protection makes sense. Like it's just so imperative, and it would make sense that that's where a lot of the innovation would come from, right? From necessity.
Yeah, I think it's also a question of money.
Right.
Because there is a bigger margin on this type of product, like a specific coverall that has several protective function. Just if I take the example of the firefighters, the gear that they wear, it costs several $1,000s just for one person. So you have more margin in terms of innovation. The cost of your innovation, you can implement it onto your product, and you still have room to fit into the market price. If we're talking about sportswear, there is a lot of innovation too, but at a smaller scale. It's more developed for the people. So it's usually you can't price out a shirt $200, for example. You have to stay in a certain range, which kind of limits the impact of the R&D onto this product.
Unless it fixes your backswing.
Well, even then, that was a hard market for the smart textiles sportswear. There is a lot of things that could have been done, but again, the issue is that you have already all range of smartwatch, right? That gives you many data on how you perform. And then you have the smart shirt, for instance, that will also give you some data, but you have to wash it a certain way to ensure its durability, and it costs almost the same price, even sometimes more, and there is more restriction on how to use it. So at the end, it's very difficult for smart textile to go into this market.
Yeah, that definitely makes sense.
Other than I guess the push on removing PFAS materials from a lot of the textile markets, have you seen any particular pushes from different industries and in textiles for sustainability and environmental or reducing environmental impact, or has it just been across all industries at this point?
So yes, we have seen many different initiatives, and we kind of have them mapped out so that we kind of know where they fall in which category they fall. Obviously, as I was mentioning, natural fiber, it's a big one. We work mostly with milkweed and hemp because they are locally produced as well. They are fiber made in Canada, so that's one initiative to replace, mostly for insulation, to replace regular insulative polyester product by, for instance, milkweed fibers. So those are one area of where there is a lot of research. We also have a lot of research in recycling. This is kind of a bigger issue. We do a lot of research, but it's complex, right? Because when we're talking about recycling product, we have the post-industrial and post-use. When it's post-use, it's such a mix of different fibers, and it's very difficult to be able to reuse that. For the post-industrial, usually you know what you have already in hand. You know the composition. Is it 100% polyester? Is it a mix? So you kind of have an amount of material that is available, and that is what we call clean in a way. So that's easier to get into this. But it's still complicated when it also comes back to the PFAS, because we are developing PFAS-free product, but then we want to use recycled materials. But does the recycled material is PFAS-free, and how can you know? And then you can do different analysis, but will you be able to do that on each load of recycled fabric that comes to your facility? No, because it will become very pricey to do. So then you have an issue of how can you ensure that if you're using recycled material, it will be PFAS free as well. That at that point, right now, we cannot say. And then there is also the issue of, okay, we have a material that is a mix of recycled polyester and regular polyester. Can you tell how many percentage is recycled or what is the actual virgin polyester? Right now, if you're doing a composition analysis, you won't be able to differentiate what's 100% virgin polyester and what's 100% or partially recycled polyester. They will have the same spectrum, they will have the same of everything. It will be a polyester all the same. So unless you have a very good traceability to ensure that it is recycled, it's also very difficult. So the recycling part, it seems sometimes easier because, especially for mechanical recycling, which is mostly what we do, it seems like, well, it's easy. You just bring the fabric to a shredder and then you continue on the loop. But it's actually much more complex than it seems. It's always like that. The project that are the most complex are always the ones that seem the simplest at the beginning.
Yeah, of course, of course. It's just amazing me. This is opening my eyes to exactly what you were saying, the complexity of just everyday assumptions, or, what you would think would be just simple instances that you can overcome, don't have to really think about. But you do have to go deeper on these ones, and you really need to analyze and go all the way, I guess. What about for CTT itself? I mean, you're helping other industries and companies become more sustainable, more ecological, but what about for your organization specifically?
Yes, so we have a committee in place, and we're looking at different things. Obviously, we do a lot of washing cycles because a lot of specification require a certain amount of washing of the materials to be able to test the before and the after, make sure that the washing hasn't deteriorate the properties of the fabric. So there is a lot of washing going on. So there is different initiatives that we are looking into. How can we reuse the water? Is there any way that we can reduce the waste of water or the amount of microfibers that may be going into those waters? So that's for the water part. For the energy part, we're also looking at different possibilities. And actually, one of the areas I haven't mentioned before, because I talked a lot about product development, but there is also an area of process development. When we're talking about finishing, there is a whole several project research that are looking into photopolymerization. So the idea is to use LED lights to be able to cure a product or finish a coating, for example. Currently, the way it's treated is that it's dipped into the formulation, and then it uses thermal energy, so it's heated and then cured. So it's in terms of energy consumption, it's a lot higher, and it takes a lot of time. Well, a lot of time. It takes some time to dry and cure the product. And then it's not all materials that are able to go through that. If there is a lot of elastane or spandex, for instance, those are materials that are very sensitive to heat. So there is a specific process that needs to take place here. Whereas if we're looking at photopolymerization, it could be a good alternative for those type of materials. And you will have the same type of finishing that will take only a few seconds instead of a few minutes. And in terms of carbon footprint, it's also very good because it's just an LED light rather than heating up a whole entire oven. So those are some examples of things that we are looking at on our own, but are not necessarily with an industrial partner, but more as an autonomous project.
Oh, that's great. I mean, you really are on the cutting edge in a lot of respects. Yeah, that seems like science fiction to me, what you just mentioned, but you're working on it, and hopefully that's something that comes to market. That sounds amazing.
Yeah, and actually it seems that photopolymerization exists since a long time. If you're looking at the dentistry, all the implants that they are doing, it's using photopolymerization. It's not a new process. It's never been applied to textile before.
Right. Yeah. Oh, that totally makes sense. Oh, very cool.
It's amazing. It's kind of making our industrial textiles seem, I don't know, a little boring by comparison. I'm getting a bit of
I know. I feel very old-fashioned here. I think you might have a new customer here.
And what, the point Ryan touched on earlier, after your earlier comments of the complexity of what you guys are dealing with, like I never would have thought, you talked about, eliminating PFAS and then trying to recycle, and that these are two initiatives with a similar goal in mind, that but then create a conflict between them. Like how are you going to recycle if there's PFAS in it or whatever? Then all that stuff has to be waste to eliminate those. Like this is like, I feel like we're literally, like it's like trying to follow a time travel movie at this point. You know what I mean? Like in terms of where you're going.
Yeah, it can be very complex. We are looking then at other option, for example, the CO2 supercritic dyeing process. It's one example of, it's one of the equipment actually that we will be acquiring this year. It's in 2024. And so the idea is to be able to potentially use this type of technology so it's meant to be used for dyeing fabric, but it could also be used to remove things from fabric. So potentially toxic elements can be removed from the fabric so that we could clean the fabric to be used after that. So there is always a solution. It's just the loop becomes a bit bigger and with a little bit more complexity into it. But there is always process and solution that can be brought into this type of project. Then the optimal thing that we have to look into, it's how much it will impact the cost.
Right.
Because right now what we are seeing is that there is solution, but since there is not like for the PFAS, it's a bit different, but for the recycling, there isn't too much push to force the industry to recycle their waste. They can still send it to be burned or
incinerated.
Incinerated, yes,
right.
Exactly. So they have still other option, and sometimes, actually often, when they look at the pricing, it costs them more to try and recycle them rather than to incinerate them. So for the PFAS, it's a bit different because with the new regulation coming into place, they won't have any other choice. Now, even if they have good intention at the end, if that costs them twice the price, the good intention will not be enough.
Right. Yeah, and I guess unfortunately it always requires regulation, in order to do it, unless you can really create that financial motivation, right? Like, and that's the difficulty. Unfortunately, the good intentions are not enough. Everybody has to look at the bottom line, and you have to find a way to monetize it.
Yeah, exactly. And there is also the concept of, if you're using recycled material into a new product, and that's something that actually CTT Group is not looking too much into it yet, but it's something that could be of interest. It's looking from the consumer point of view. Will you want to buy a product that has a certain percentage of recycled material? Right. Potentially, yes, because now it's kind of a trending. So you want to have a green certification of some sort. You want to be you buy more local, and so this is things that are being put in place, and that's great. But in some cases, it's not so easy, and it depends what's recycled. When we talk about recycled material, where it comes from, right? There is potentially some areas where you wouldn't want to reuse. We had a project a while back, where it's a few years back. We were trying to use a chicken feather as an insulative media. So we're thinking, well, the down fabric, it's so expensive when it comes from duck, goose. The chicken doesn't have the same properties, but there is a portion of it that still does. And the chicken feather, it's everywhere and it costs nothing. So can we reuse that, transform it, and get the down portion of the chicken feather to be able to create some sort of insulation media? Well, it's the concept is good, but then if you are doing a poll of consumers, and if they will accept to have chicken feathers, like, oh, will it smell? They're not, oh yes, that's great, I will buy it. It's not so easy. The jump is not there just yet.
And that's so funny. It's just perception, because really, what's the difference between a chicken feather and a duck feather, or like it's
if it's inside a jacket, it's same as far as I'm concerned.
Yeah, exactly. it's all perception. And I guess, you hit the nail on the head, Justine, with, in the end, it's really up to us. It's in our hands as consumers. We vote with our dollars. We're the ones that can kind of make the change, but sometimes it's just difficult to get that movement happening on a mass scale so that everybody is, on the same page. But it sounds like, as CTT is really, to Ryan's point earlier, you guys are really at the forefront of this stuff and making that headway and hopefully, pulling us all in the right direction towards, more sustainable options in whether it be in textile, well, our textile industry, or any industry that's using textiles. So, we certainly appreciate the fact that you're there, and hopefully this is going to shed some light on what CTT Group does and what you're capable of doing, and the contributions that you can make to an industry like ours, and to some of the manufacturers that are out there that might really need some help and some accompaniment in some of these initiatives. So, really appreciate you, taking the time to join us today on the podcast. This has been amazing, and I really hope actually that we'll get to do this again, and maybe even have some of your other colleagues on, because this is fascinating stuff, and I really think our listeners are going to enjoy this. So thanks very much for joining us today, Justine. It's really appreciated.
You're very welcome. It was my pleasure.
Thanks, Justine.
Well, that's it for this episode of Talking Textiles. So I'll thank all our listeners for joining us, and hope you enjoyed it.
Thank you for joining us for this episode of ATA Talking Textiles. ATA is a not-for-profit association representing the international specialty fabrics marketplace. Learn more about the events, workshops, and webinars ATA hosts throughout the year at textiles.org/events.